In this video, we're going to go into Chapter 3, Section 2, and talk more in detail about slopes. You may have heard that slope is rise over run. That's the vertical change between 2 points divided by the horizontal change, or the change in y divided by the change in x. It's the rate of change of y as x goes up by 1, essentially. And so here we have a formula for slope. Slope is equal to m, which is what we normally call slope, is equal to y2 minus y1. That's the second y coordinate minus the first y coordinate, which gives you the change in y, over x2 minus x1. That's the second x coordinate minus the first x coordinate, which gives you the change in x. So you can see that over on the right, you have the change in y, y2 minus y1, over the change in x, x2 minus x1, and that quotient, or that ratio, is what we call the slope. So in this section, one of our learning objectives is to be able to calculate the slope for any non-vertical straight line. What we mean by non-vertical is that a vertical line has an undefined slope. So any other slope, any other type of line besides a vertical line, has a slope that can be calculated. And so we'll learn how to calculate slopes in this section. And then we want to be able to determine whether two lines are parallel or perpendicular just by looking at their slopes. So these are two learning objectives that we will cover in this section. Let's get started. Okay, so in example 1, here we actually have a graph. We have 2 points. So we can calculate the slope of a line just by looking at its graph. And so let's plot these 2 points and then talk about how we might be able to calculate the slope of the line connecting those 2 points. So we're starting with x is -2, y is -3. X is -2, y is -3. Then we have the point x is 1 and y is -4. X is 1 and y is -4. So we have these 2 points and we can draw a straight line through those 2 points. What would be the slope of that line? Well, by looking at the graph, we can, as we talked about in the previous section, we can count down 1 unit, which tells us the slope will be negative. And then we count over 3 units. So our slope would be m is equal to -1 over 3. If we go down from left to right, then we have a negative slope. If we go up from left to right, we have a positive slope. So we'll talk about all of these things here. All right, so let's see how we would calculate this, though, using the formula that we were given earlier, and to show that these two things turn out to be the same. So let's label our point here. We have x1, y1. x1 is -2, y1 is -3. x2 is 1, y2 is -4. So our formula was y2 minus y1, the change in y, or the rise, over x2 minus x1, the change in x, or the run. So what we're going to get here when we substitute, y2 is -4. Now you have to be really careful. The minus sign always goes there. Then we have minus y1, which is -3. So we don't just write -4 minus 3. It's -4 minus -3. And that's going to be an important distinction. If you don't write that down correctly and make the calculation or perform the calculation correctly, you're going to have an incorrect slope here. All right, change in x. X sub 2, that's 1, minus x1 is -2. Again, notice the negatives. It's y2 minus whatever y1 is, x2 minus whatever x1 is, whether they are positive or negative. All right, so we have -4, and you might remember that minus a negative is the same as positive, and then 1 minus a negative again is going to be positive. So we have -4 plus 3 is -1. 1 plus 2 is 3. So we could have calculated this easily or more easily just by looking at the graph. We won't always have the luxury of having a graph. Sometimes the values we're given are not easy to plot on a graph. And if the graph is not, if you hand draw a graph and plot the points, the graph has to really be accurate. Otherwise, you could calculate the slope incorrectly. All right, so there we have it. It's we can, if we're given a graph with 2 points on it, we can count up or down and to the right. We always start from left and move to the right when we're calculating slopes. If we go up, it's positive, right, or down is negative and to the right. All right, let's go on to the next example. All right, so this time we don't have a graph, but this is an opportunity for you to practice using the slope formula. So pause the video, carry out the calculations, and come back and check your work. All right, let's get started. So we know that slope is equal to y2 minus y1 over x2 minus x1. And I'll usually write the formula because one, it helps me remember the formula. And second, once I have all the pieces there, I can plug in what I need and the calculations are not are more straightforward. All right, next thing that I'd like to do is I'm going to label my points, the coordinates on each point. So I have x1, y1, I have x2, y2. And now I'm going to begin to plug them in. y2 is -2 minus y1 is just 1. x2 is -5 minus x1 is -6. So the numerator, -2 minus 1, is going to be -3, -5, plus 6. So we'll write that intermediate step there, and we get -3 over +1, and so we have a slope of -3. Now, when we're on a graph, it's good to have a fraction there. So if there is no denominator, it's good to have a 1 there. It tells you to go, in this case, from the left point, go down 3, right 1, and you will get to the next, to another point on the graph. Then from there, down 3, right 1, etc. But when we just talk about the slope, we don't need to divide by 1. Any number divided by 1 is itself, and so it's easiest to just say that the slope is -3 here. Okay, let's go on to another example. Well, before we talk about another example, something that has come up in the conversation, but let's just solidify the idea here. If, as you move from left to right, from one point to another point, if you move up as you go from left to right, then the slope will be positive. So on the left here, we have 3 slopes. One is a slope of 1/3, a slope of 1, and a slope of 3. So lines that slope upward to the right means as you move from left to right, they go up, have what we call positive slopes. And lines that slope downward to the right, that means if you go down from left to right, we say that those slopes are negative. Now, how about a horizontal line? Well, a horizontal line has a slope of 0 because there is no change in y. But a vertical line has an undefined slope because there's no change in x, and since x is in the denominator, a change of 0 will have you dividing by 0, and that can't be done. That's undefined. So slope from left to right, if you go up as you move from left to right, positive slope. If you go down as you move from left to right, that's a negative slope. If you stay the same as you move from left to right, that's a 0 slope. And if you have a vertical line where you're not moving from left to right, there is no horizontal change, then we say that the slope is undefined. All right, so let's find some more slopes. This time we have slopes that involve decimals, and we also have slopes that involve fractions. So we're going to use these opportunities to to improve our skills at working with decimals and at working with fractions, while at the same time we're learning about slopes. So one thing that I'm always going to do, label my points, x1, y1, x2, y2. Let's do the first example first. Then write my formula. M is equal to y2 minus y1 over x2 minus x1. I'm going to substitute my values. Y2 is 1.8 minus y1 is 2.3 divided by x2, negative 6.4 minus 1.6. Now, if you would like to, you can call out your calculator here, and let's see what we get. So we have 1.8. 1.8 minus 2.3 equals negative 0.5. So we have a negative 0.5 divided by, and next we have negative 6.4 minus 1.6. And here we would have a negative 8. So it's clear that a negative divided by a positive is a negative divided by a negative, sorry, is going to give us a positive. And if we wanted to divide now, negative 0.5 divided by negative 8, that will give us 0.0625. 0.0625. And if you want that as a reduced fraction, you can go to the calculator under Math, which is right here, Math, and right there you can see option 1 is fraction. And so notice that it says answer, fraction, and we get 1 over 16. So we didn't have to type in the answer. We could have hit, notice down here by the negative symbol, in yellow it says answer. So if we did second negative, that would bring up the answer. And then Math, option 1, allows us to convert that to a fraction in simplified form. So that is helpful as well. All right, so the slope of that, the slope passing through the first pair of points there is 1/16. All right, we'll go on to the second example here, and we'll label our points x1, y1, x2, y2. And so our formula is m is equal to y2 minus y1 over x2 minus x1, plugging in our points, negative 1/4 minus negative 1/2 over 2/3 minus 5/3, and we get negative 1/4 plus 1/2, which will give us a positive 1/4. And then we have 2/3 minus 5/3, which would give us a negative 3/3 or a negative 1. So we would have a slope of negative 1/4 here. Now we can go to our calculator, and let's see how we might accomplish the same thing here. So when you have fractions, be careful. Let's put the whole numerator in parentheses. So we're going to have negative 1 divided by 4 minus parentheses negative 1 divided by 2, close parentheses, divided by open parentheses 2 divided by 3 minus 5 divided by 3, close parentheses, and we get negative 0.25, math, fraction, negative 1/4. Now that went pretty fast, but you can review the video and see how that works.